Hi, I'm Ben Nazette, Director of Product at Liquid Instruments. Today, I look forward to sharing with you the benefits of a modern PID controller and how to use the one available for Moku Pro to accelerate your research. Now, a proportional integral derivative controller, or PID controller, is a common tool in scientific and engineering labs. It continuously calculates an error value between a set point, or the desired value, and the actual value of some parameter you want to control. The output of a PID controller is given by the magnitude of the error signal, as well as how quickly it's changing and how long it's been away from zero. In other words, the output is a proportion of the error signal, along with a proportion of its derivative and its time integral. The Moku Pro PID controller has some extra features as well, including a second integrator for extra low-frequency gain, and configurable integral and derivative saturation points to help achieve the best outcomes in noisy or high-disturbance environments. PID controllers are really the workhorse of real-time control applications. You can use them to control lasers, motors, servos, piezoelectronics, and much more besides. While PID controllers are incredible standalone tools for feedback control, they only work if they have a trustworthy measurement of the system's actual state. At Liquid Instruments, we've engineered our high-performance laser lockbox and lock-in amplifiers to have some built-in PID controllers, combining the ability to take extremely precise measurements of a system with that of directly controlling it with no added delays or noise. With sub-microsecond latency, the software-defined PID controllers available for Moku devices provide fast feedback for highly sensitive test systems that can be susceptible to environmental changes. Now, let's dive a little deeper into the capabilities of the Moku Pro's PID controller. Traditionally, low latency meant analog PID control, and that meant soldering op-amps and filter components and stressing about noise and repeatability. The Moku Pro PID controller provides a much more convenient digital way of achieving your objectives. Thanks to its speed and high-quality digital signal processing, you can use the Moku Pro PID controller to unlock a lot more power and flexibility. Moreover, since Moku Pro gives you the ability to use more than 12 embedded instruments, the PID controller is more tightly integrated with other capabilities, like lock-in amplifiers and filter boxes, data loggers, and more. Record your inputs and their responses, you can apply pre- and post-filters, and get real insight into your system from a single device. The software-defined instruments reside on powerful hardware to enable advanced testing. Moku Pro utilizes a patented ADC blending scheme to deliver a low noise floor and a high dynamic range from DC all the way up to 600 MHz. Now, this is very important for wide bandwidth control, as it allows you to increase your control gains without getting swamped by noise. The Moku Pro has 4 analog inputs and 4 analog outputs, enabling true multi-input, multi-output, or MIMO control schemes. The PID parameters, such as gains and saturation points, can be adjusted in real time by simply dragging around features on the controller's transfer function. The built-in oscilloscope allows you to probe and measure any part of your signal chain, giving you real-time feedback on how your tuning is affecting critical metrics such as rise time and overshoot. The PID controller is tightly integrated with the lock-in amplifier and the laser lockbox, but it can be easily combined with any instrument in multi-instrument mode. Multi-instrument mode allows you to run up to 4 instruments at the same time and connect them together however you wish. For example, the phase meter instrument itself does not have a built-in PID controller, but if you want to use it as a wrap-free phase detector in a control loop, then you can drop that in, drop the PID controller in after it, and wire them both up to inputs and outputs as needed. Another common configuration here is to connect the PID controller and the frequency response analyzer. This allows you to get full frequency domain characterization of your closed-loop control system. With Moku Pro, you're not limited just to the instruments available on the device either. You can use Moku Cloud Compile to code and deploy custom features directly to your Moku. For example, you can quickly deploy custom algorithms that pre-process your error signal, maybe linearizing it or filtering it, before the signal enters your PID controller. A simple example here might be when detecting power but controlling voltage. You can take the square root of the input signal before the controller, greatly increasing the effective dynamic range of the system. To optimize performance in a range of applications, the PID controller is available on all our Moku devices, from the affordable and highly portable Moku Go to our workhorse Moku Lab and right up to our flagship Moku Pro, which is designed for the most demanding applications. Simply choose the specifications and price that meets your needs. To learn more, visit our website or contact us at info@liquidinstruments.com for a live demo. Thanks for watching.